Alright, so if I do a good job, this should be an easy section. There's a few problems in this section that make it on the test for Chapter 1 that students miss a lot. So maybe in the last video I just wasn't clear enough on what I needed to be clear on. So let me try to make it better this time through, because this stuff really shouldn't be that hard. So the beginning of this section, the section's titled Subsets, we'll introduce a couple definitions, just like kind of every introduction for the sections in this chapter. There's just lots of different definitions that we need to learn. So we'll start this section learning the definition of two terms, and they're basically the same term, except one has an extra word. So subset and proper subset are the words that we need to have definitions for, and they're similar. The definitions will be similar. There's just a slight difference. When I think subset, in some sense, I think less than or equal to, and I'll get to that in a second. When I think proper subset, I think less than but not equal to. Somehow the concept of a subset and the concept of less than and less than or equal to, they're kind of similar in some sense. So again, for some reason, this concept is missed a lot on tests. Pay close attention to the difference between these definitions, otherwise you'll lose points on the test that you don't need to lose. So now we'll do the definition of a subset, and this is the symbol for subset. Notice I put less than or equal to up here. That's not really the symbol, but it's kind of similar to a less than or equal to in terms of how it works. But this is the symbol for subset. So the symbol for subset is that symbol. And in order to talk about the concept of subset or proper subset, you need to have two sets that you're comparing. And I'll give these sets names A and B. And we say that A is a subset of B, symbolized A is a subset of B with that kind of curved less than or equal to sign, if and only if all the elements in set A are in set B. So super easy to tell if something's a subset or not, because to be a subset, you just need to meet a really low bar. And let me talk about that on the next page. This symbol allows the sets to be equal. That's a big deal. So we say that A is a subset of B if two conditions hold. First and foremost, A has to be a set. To be a subset of a set, you have to be a set. If A is not a set, then it can't be a subset. And then this notation here says if X is in A, then X is in B. The second condition means every element inside set A is also an element inside B. Let me go to my next page and show you some examples of sets to figure out whether a set A is a subset of set B or not. So on this page, I do an example, and it says, is A a subset of B? Given A equals the set that equals A, B, C, and D, and B is the set A and B. So we just need to check the rules. One of the first rule is A has to be a set, and the bar for being a set is really low. Essentially, any collection of objects can be a set just as long as we call it a set, and A is a set because it's a collection of these four letters and it's in set braces. So A is a set. Now every element in set A has to be in set B, means A has to be contained in B. In some sense, A has to be less than or equal to B. And when I look at A, it's bigger than B. It's in some sense greater than B. A has two elements in it, C and D, that aren't in B. So A isn't less than B, it isn't contained or equal to B, so it's not a subset because there's two elements in A that aren't in B. When I look at the symbol, the subset symbol, I think of this as either A is contained but not equal to. That's that part of the symbol. And this part is or A is equal to. So for this symbol to be true, either A has to be equal to B, or A has to be contained but not equal to B. A isn't equal to B because they don't have exactly the same elements, and A isn't contained in B because there's two elements of A that aren't in B. So every element in set A has to be in set B, and A has C and D. So this violates the A is contained in B. So A is not a subset of B. Now, the letters A and B don't have to be the only letters that I use to compare sets to figure out if the left set is a subset of the right set. So on the next page, I change up the letters a little bit, but the rules will kind of work the same way. So on the next example, I'm asked, is set S a subset of set T? So I look at my two sets. I look at my set S and my set T, and I ask myself, first of all, is S a set? And then S is a set because it's a collection of three numbers. It's in set braces, so S is a set. So there's two rules to be a subset. The first of the two rules is the left-hand item needs to be a set, which it is. The second rule is that every element in set S needs to also be in set T, because we're trying to see if S is contained or equal to T. If I look at the elements of set S, there's a 1 in S, there's also a 1 in set T. There's a 2 in set S, there's a 2 in set T. There's a 3 in S, and there's a 3 in T. Even though S doesn't equal to T, because every element in set S is contained in set T, then we say yes, S is a subset of T. So the first rule was satisfied because S was a set. The second rule is satisfied because every element in set S is also in set T. So rule 2 is satisfied. So both rules are satisfied. So if I ask the question, is S a subset of T, I can say yes. Set S is a subset of set T. This next problem is tricky because I wrote it backwards. So I give you two sets. S has the letters A, B, C, and D. T is a set that contains A and B. And I said, is set T a subset of set S? That's the question here. And what would it mean for set T to be a subset of set S? What would we need? We need two things. We need T to be a set. So I'm first going to make sure T is a set, and to be a set, really, we just need the set braces. So T is a set because it's the set of the objects A and B, and it's a set because it has the curly set braces. Now, second, for T to be a subset of S, every element in set T needs to be in set S. So if I look at the first element in set T, it's A. There's one of those in set S, so that's good. The second element in set T is a B. There's a B in set S, so that's also good. So T is a set, and every element in T is also an element in S. That means yes, T is a subset of A because both rules are satisfied. So the answer to is T a subset of S given S is that set and T is that set, the answer to the question is yes. This is just a yes-no question. Either T is yes, it is a subset of S, or no, T isn't a subset of S. Alright, so another example. I give you two new sets. I give you the set C, which is the set that contains 1, 2, and 3, and D, the set that contains the numbers 3, 1, and 2. And I ask, is C a subset of D? So what two rules do I have to have? I need C to be a set. C is a set because it has the set braces. The numbers inside of it are less important than these set braces. C is a set, and to be a subset, you have to be a set, and every element in the set, the left set, has to be in the right set. So to see if C is a subset of D, every element in C has to be in D. Well, 1 is in C, 1 is in D, so 1's not a problem. 2 is in C, 2 is in D, that's not a problem. 3 is in C, 3 is in D, that's not a problem. Rule 2 is satisfied because every element in set C is also an element of set D. So the answer is C a subset of D? The answer is yes, C is a subset of D because it meets the two rules. C is a set, and every element of C, 1, 2, and 3, is also an element of D. I made a comment to myself, it wasn't asked, but it would also be true if I asked, is D a subset of C? For the same reason. D is a set, so it satisfies rule 1, and the 1, the 2, and the 3 are the 3, the 1, and 2 that are in D are also in C. So both of these are true for this statement. For these two sets, C is a subset of D, and D is a subset of C. Those both statements would be true statements. One more example, and then we'll move on to the proper subset. So for these two objects, is A a subset of B, given A is the numbers 1 and 2, and B is the set that contains the numbers 1, 2, and 3. This is an intentionally tricky question. When I look at A is not a set because it's not in set braces. And to be a subset of a set, you have to be a set. And so the first rule is violated here. A is not a set because it's not in set braces. Rule 1 is not satisfied. I can stop checking the rules because both rules have to be, I have to answer yes to both rules for A to be a subset of B. Because A is not a set, it can't be a subset. So the answer would be no. I say A is not a subset of B. And I guess symbolically I could say this: A is not a subset of B. A little slash line through that symbol means not. So that's the first definition that we needed, the definition of subset. The next definition, so the symbol for subset that we've been working with so far is this symbol. And this symbol is true when two things are met. The first letter, or the first object, or the first name represents a set, and every element in that left set is also contained in the right set. This symbol allows the sets to be equal. When we get onto the next page, we're going to be given a definition for proper subset. The symbol for proper subset doesn't have the or equal to part of it. It's just a subset symbol without kind of the or equal to. This symbol right here, for it to be true, it's only true if two criteria are met, and the second criteria won't allow the sets to be equal. Let me go ahead and, well, I guess I did it with 3 criteria on this next page real quickly. So let me flip to the next page and talk about the difference between subsets and proper subsets. And the big difference between subsets and proper subsets, A can be a subset of B if it's equal or contained. A can only be a proper subset of B if it's not equal but it's contained. It's kind of the big difference between the definitions. So on the next page here, I typed up a definition of a proper subset given the symbol without the equal sign. And we say A is a proper subset of B, symbolized by A as a proper subset of B, if and only if these 3 conditions hold. A is a set, same condition. Every element of A is also in B, same second condition. Snuck on a third condition saying A can't be equal to B. So to be this is enough. If you satisfy those, you can be a subset, but you're not a proper subset. To be a proper subset, you have a third criteria. You have to be a set, you have to be contained, A has to be contained in B, and then A can't be equal to B. So basically this symbol is true when A is a subset of B, but it's not equal to B. So let's do some examples just to check these out. So is A proper subset of B, where A is a set that contains 1, 2, and 3, and B is the set that contains 1, 2, 3, and 4. So we need 3 criteria. The first criteria is A has to be a set. A is a set because it's written in set braces, so rule 1 is satisfied. Second criteria is every element of A also has to be in B. A contains 1, B contains 1, A contains 2, B contains 2, 3, A contains 3, B contains 3. So I satisfied the second criteria that every element in set A is also in set B. But I have this third criteria for the proper subset symbol. The third criteria is the sets can't be equal. If the sets were equal, I'd have to answer no to this question, but these sets aren't equal because B has an extra element that A doesn't. So the third criteria is satisfied. All three rules are satisfied, so we say A is a subset, a proper subset of B. A lot of times I'll say subset here. I should always say proper subset because there's a difference in the symbols. This symbol right here is the subset symbol, and for this to be true, you only need to meet the first two criterias. This symbol, the proper subset symbol, you have to meet that third criteria that the sets aren't equal to each other. So let's look at a couple more sets. Is S a proper subset of T given S has the elements A, B, C, and D, and T is a set that contains A and B? So there's three rules that we need to check, and if the answer to any of the three rules is no, then I'm done, and the answer to this whole question is this is not a proper subset. First rule, S has to be a set. S is a set because it has the set braces. So I've satisfied rule 1. Second rule, every element of S has to be contained in set T. So let me look at the elements of S. A is in S, it's also in T. B is in S, it's also in T. But C and D are in S and they're not in T. So it's violating the second rule. There's two elements in S that aren't in T. So I violated the second rule because every element in set S needs to be in set T. That's not good because S has the elements C and D that T doesn't have. So rule 2 isn't satisfied. I don't need to check rule 3 as rule 2 has already been violated. So all three rules aren't satisfied. So S is not a proper subset of T. My answer could be no to this question. This is a yes/no question. Is S a subset of T? Either my answer would be yes, S is a subset of T, or no. Then I have a double negative here, which probably isn't so good. S is not a subset of T. I guess my answer would either be no or S is not a subset of T. By saying no here, I mean S is not a subset of a proper subset of T. I get lazy, and when I see this symbol, I don't always think proper subset, but it's real important to remember that there's a difference. This symbol, the proper subset symbol, there's three rules that you have to satisfy. The same first two rules along with the third rule that you can't be equal. And the subset symbol, for that symbol to be true, you only need to satisfy two rules instead of, you don't have that third rule there. All right, here's another example. Is T a proper subset of S given S is the set that contains A, B, C, and D, and T is the set that contains A and B? So let's see. I'm trying to see if T is a proper subset of S. So for T to be a proper subset of S, I need three things. T has to be a set, and T is a set because the set braces. So there's three rules. The first of the three is the left object needs to be a set, and it is. The second rule is every element of the first object needs to be contained in the second. So every element of T needs to be an S. T has an A in it. There's an S and A, so that's good. T has a B in it. S has a B in it. The second rule is satisfied because the two elements A and B of T are also elements of S. So the second rule just means every element in the left set is also in the right set, and they are. Third rule, because this is a proper subset, T and S can't be equal to each other, and they're not equal because S has a couple extra elements in it, so the sets aren't equal. So all three rules are satisfied, and the answer would be yes, T is a subset of S, a proper subset of S. So again, I get super lazy. I have to be so careful to not call that subset. I call that proper subset as opposed to subset. Subset again has that as a subset. I have to just keep reminding myself because I forget as often as you do, because I don't do a lot of subsetting in any other class. So it's super important that subset, it's okay to be equal. And we just need to satisfy the top two rules. Proper subset, it's not okay to be equal. And we have three rules to satisfy, and that third rule says they can't be equal. All right, let's see this. Is C a proper subset of D, given C is the set that contains the numbers 1, 2, and 3, and D is the set that contains the numbers 3, 1, and 2. So we have three rules that need to be satisfied. The first rule is C has to be a set. C is a set because of the little squiggly brackets, so rule 1 is satisfied. Rule 2 is every element of C also has to be an element of D. The three elements of C, 1 is in C, 1 is in D. 2 is in C, 2 is in D, 3 is in C, 3 is in D. So the second rule is satisfied because the three elements of set C are also in set D. Third, are the sets equal? They're not allowed to be equal. Because these sets are equal, we're going to violate rule 3 because the sets can't be equal. So that means C is not a proper subset of D. My answer to this can either be no, or I can say C is not a proper subset of D. So many examples. All right, let's look at one more example before we get to a kind of an odd example. So, is A a proper subset of B given A is the numbers 1 and 2, and B is the set that contains 1, 2, and 3? For this to be true, I need to satisfy all three rules, and the first rule requires A to be a set. A is not a set, so I violated the first of the three checkings. I don't care about the rest of the three checkings because all three checkings need to be true. Because A is not a set, then we can't say that A is a proper subset of B. So the answer is going to be no. Or again, I can say A is not a proper subset of B. The next thing is a little bit tricky. I don't usually put it on a test. Some teachers love this so much, but the empty set and subsets can be a little bit tricky. So we didn't do much with the empty set in section 1.1. We'll do a bit with it now. Remember, the empty set is a set with no elements, and it can be expressed two ways. So the empty set is a set that contains no elements. And I like doing this to represent the empty set. I write the set braces with nothing inside of it. That means that's a set that has no elements. But a lot of teachers, a lot of students will write a 0 with a line through it. That also means empty set. These have the exact same contents. These are a set with no elements. On the next page, I talk about a fact that is maybe not obvious, but it's true. I don't think I've ever put this on a test, but fact, the empty set is a subset of every set. This is it's just a mathematical fact because the definition holds. In fact, the empty set is both a subset and a proper subset of every set. I could probably say that. So I can say the empty set is both a subset and proper subset of every set I guess as long as the second set isn't also the empty set to be a proper subset. So let's talk about if I had the empty set, and I'm going to prove the empty set. The empty set is a subset of set A for any set A. Well, to be a subset, you need to satisfy just 2 rules. To be a proper subset, we need to satisfy 3 rules. Well, let's look at the first 2 rules. The first rule is satisfied because the empty set is a set. To be a subset of any set, an arbitrary set, you have to be a set. And then rule 2 would have to be satisfied, and rule 2 would be every element in the left set is also in the right set. Well, there's no elements in here, so you can't violate that. There can't be an element in this set that isn't in that set because there's no elements in that set. So this little blurb here says, rule 2 is satisfied as everything in the empty set is in every set A. For this rule to be not satisfied or to be violated, there needs to be something in the empty set that's not in set A. Since there's nothing in the empty set, this rule is satisfied. So it's a set, so rule 1 is satisfied. And by default, because there's nothing in it, there can't be anything in it that's not in the right set. So rule 2 is satisfied. And then rule 3 will be satisfied as long as A is not the empty set. The only way this symbol, which is equivalent to this, the only way I could answer no to this is if the set A was also the empty set. So the empty set is both a subset and a proper subset of every set, as long it's only a proper subset if they're both not the empty set. All right, so let's do an example of this, and then it doesn't come on the test, so I just do one example. This says, is C a proper subset of D given C is the empty set and D is the set that contains 1, 2, and 3? Technically, we have 3 rules. Rule 1, C has to be a set. And C is a set because it's an empty set. The rule 2 is the tricky one. It says that every element of C must also be an element of set D. And this by default is true because there isn't any element in C that's not in D. So this is the sneaky true. And for rule 3, because this is proper subset, set C doesn't equal set D. It meets all 3 rules. It kind of oddly meets the second rule. So we say yes, C is a proper subset of D. There are not going to be any empty subsets on the test, so I'll only do one example just in case you see it somewhere else. All of a sudden I come up with homework questions here, and I ask you to answer true or false as opposed to yes or no. It kind of bugs me that I did that, but true is going to be similar to yes, and false is going to be similar to no. I probably should have changed the answer yes or no. But I didn't, and so I'm going to just roll with the homework here and see how it goes. So answer yes or no, or answer true or false. If false, tell me which reason is violated. So question 2, is A a subset of B given A is Phoenix and B is a set that contains Phoenix, Glendale, Peoria, and Scottsdale? The problem here, to be a subset, I need to satisfy 2 rules. Rule 1 is A has to be a set. A is not a set because there's not in the set brackets. So for my answer, I'm going to say, is this statement true? I'm going to say false, which is kind of equivalent to no. And the reason is because A is not a set. If you said no to be consistent with what I did, as a matter of fact, let's just change that. Let's just do that. Let's answer yes or no. And if no, give the reason. And I'll just change the instructions in the homework, because that bugs me. And I'll change my answers so I'm consistent with what I have been writing. So let's, on the fly, change this instructions to say answer yes or no. If no, give the reason. So your problem 1 is A a subset of B, given A equals the element silver, B equals a set that contains silver, gold, and diamond. And of course, you're going to violate rule 1 as well, because A is not a set. So you're going to say no for your answer, and you're going to say because A is not a set. All right, let me move on and do number 4. Is C a subset of D, given C is the set that contains silver, D is the set that contains gold, silver, and diamond? I have 2 rules. C needs to be a set, which it is. So rule 1 is satisfied. And rule 2, every element in set C needs to be an element in set D. Well, there's only one element in set C, and it's also in set D. So my answer to this is just going to be yes. Or I could say yes, C is a subset of D. Your question 3 should be real similar. When I look at 5 and 6, they're a little bit different. So I'll let you do 5, and I'll move on to my number 6. 6 says, is A a subset of B, given A is the numbers 2 and 3? Immediately, A is not a set. And in order to be a subset, you have to first be a set. So my answer to this is going to be, is A a subset of B? I'm going to say no. And if I write a no, I need to tell you which of the 3 reasons, or which of the 2 reasons in this case it violates, and it violates A is not a set. Your question 5 is similar but different. On the next page, when you go to do year 7, is A a subset of B, given A equals the letter A and B equals the set of all X such X is a vowel, you're going to be able to answer yours real quickly, because your set A isn't a set. So you're just going to say no because A isn't a set. Let me look at mine. Is A, number 8, is A a subset of B, given A is a set that contains A? So rule 1, A is a set. Rule 2 means every element in A needs to be also in B. And B is written in kind of set builder notation. B is a set of all X's that X is a vowel. I know it's at least A, E, I, O, and U are in set B. I don't know if I want to put Y there or not. But in order to answer yes or no, A is the only thing that needs to be in set B. And because A is in set B, every element of set A is in set B, my answer to number 8 is going to be yes. Or yes, A is a subset of B. Apparently I snuck a couple of empty setters in here. I don't put them on the tests, so it's not so important. But for your number 9 and my number 10, My number 10 is S a subset of T, given S is the empty set and T is a set that contains 1, 2, and 3? I'm just going to write down yes, because the empty set is a subset of every set and not even go through the rules. And you can just write yes for your problem 9. (11) and 12 are asking if S is a proper subset of T, and to be a proper subset, you have to be a subset that's not equal. S is a subset of T because the empty set is a subset of every set, and it's not equal, so I'm going to say yes. S is a proper subset of T. My answer just needs to be S. The empty set is a subset of every set. It's a proper subset of any set that's not the empty set. And again, I'll throw that on the test, so don't worry so much about that. What we will worry about is problems like 13 and 14 because they're tricky. So is A a proper subset of B given A is A, B, C, and D, and B is D, C, B, and A? There's 3 rules. Rule 1, A needs to be a set. And that's fine because I have the squiggly brackets. Rule 2, to be a proper subset, every element in A is also in B. And that's fine because every element, A is in both sets, B is in both sets, C is in both sets, and D is in both sets. Every element in set A is also in set B. That's okay, but it's the rule 3 that says A can't equal B. This is the rule that's violated. And so my answer to this is A a subset of proper subset of B. I'm going to say no. And the reason why is because A is equal to B and it's not allowed to equal to B. To be a proper subset, you can't be equal. That should be real similar to your problem 13. Let me do 15 as opposed to 16. So let me skip on 16 and do 15. So is C a proper subset of D? I need 3 rules to be satisfied. First rule, C needs to be a set. Because I have the set braces, that rule satisfied. Rule 2, every element in set C needs to be an element in set D. And this is where in problem 15 I'm going to mess up, because there's an element in set C that isn't in set D. So boom, I've violated rule 2. I don't need to move on to rule 3. My answer to this is C a proper subset of set D. I'm going to say no, because I'll say 5 is an element of set C that is not an element of set D. That's why rule 2 is violated, because for rule 2 to be true, that every element in set C has to also be in set D, and it isn't. So C is not a proper subset of D. Okay, for me, in problem 18, is A a proper subset of B? I have rule 1, A needs to be a set, and A is a set. Rule 2, every element in A needs to be an element of B. So let's look at my elements of A. I have an E in A, there's an E in B, so that's not a problem. There's a B in A, there's a B in B, that's not a problem. There's a C and a C, a D and a D, an A and an A. Every element of A is in B, so rule 2 is satisfied. Rule 3, because this is a proper subset, A is not allowed to equal to B, and A doesn't equal to B because B has an F in it that A doesn't have, so rule 3 is satisfied that they're not equal. My answer to problem 18 is going to be yes, because it satisfies all 3 rules of being a proper subset. There isn't really anything new for the rest of the section, but there's some new problems, and these are the problems that are most missed on the test from this section. And I kind of wish they weren't, but they just are. So let's look at an example here. Given set A equals a set that contains the numbers 1, 2, and 3, and B is the set that contains the numbers 3, 2, and 1, determine which of these is true. Choose every answer that is true, and in many instances there'll be more than one correct choice. So I give you a bunch of different symbols. Specifically, I give you 1, 2, 3, 4, 5 different symbols, and for these 2 sets, A and B, I need to determine which of these 5 symbols are true. And it could be that none of them are true, and if none of the 5 symbols are true, I'm going to write none of these for an answer. It could be that 1 is true, it could be that 2, 3, or 4 are true. I have to do one symbol at a time and figure out if it's true or not, and if it's a true statement, then I'm going to include it in my answer. So let's look at option 1. Is A equal to B? Well, these are equal sets, because for equal sets, they have to have exactly the same elements. The order doesn't matter. So A equal to B, this is going to be true for this one, so it needs to be part of my answer because those sets are equal. Now I go on to the second symbol. Is A a subset of B? Let me talk about this. Is A a subset of B? Well, there's 2 rules that needs to be satisfied. A has to be a set, and it's a set, and that's rule 1. Rule 2 is every element of A needs to be an element of B. It's okay if they're equal because I don't have the third rule here. 1 is in A, 1 is in B, 2 is in A, 2 is in B, 3 is in A, 3 is in B. So I'm going to say A is a subset of B because it satisfies the 2 rules to be a subset. A has to be a set, and the 3 elements in A have to be in B, so that's also true. And that's kind of what I go on to say here. I say A is a set, and every element in set A is in set B. Let's move on to the third symbol. Is B a subset of A? Well, there's 2 rules for B to be a subset of A. The first rule, B has to be a set, which it is, so rule 1 is satisfied. The second rule, every element in B has to be in A. There's 3 elements in B. There's a 3, a 2, and 1 in B, and there's a 3, a 2, and 1 in A. So every element in set B is also in set A, so rule 2 is satisfied. So this is also a true statement. Let's move on to the fourth symbol. Is A a proper subset of B? And for A to be a proper subset of B, you have to satisfy 3 rules. A has to be a set. Every element of A has to be contained in B, but A can't be equal to B. These symbols right here have the third rule that we have to say no if the sets are equal. So A is not a proper subset of B because A equals to B. So this symbol is not going to be part of my answer. This symbol is not true. It satisfies the first 2 criteria for it to be a proper subset. It's a set and it's contained, but it's equal, and that's no good. For the fifth and final symbol that I'll check, is B a proper subset of A? For B to be a proper subset of A, B has to be a set, which it is. Every element, second rule, every element of B has to be in A, which it is. The third rule messes up because B can't be equal to A when you have the proper subset symbol. So that's not true. So when I go to write an answer to this, my answer needs to be any of the symbols that are true, and these three symbols were true. A was equal to B, A is a subset of B, and B is a subset of A. All right, let's do this again with a different sets A and B and figure out which of these are true. So A is a set that contains 1 and 2. B is a set that contains 3, 2, and 1. I need to, one rule at a time, figure out if they're true. So the first symbol I see is A equal to B. And for that to be true, they have to have exactly the same elements. That's not going to be true because B has a 3 and A doesn't have a 3. So I'm not going to include that symbol in my answer. Let me move on to the second symbol. Is A a subset of B? Well, let me talk through this. Is A a subset of B? There's two rules that have to be satisfied. The first rule is A has to be a set. A is a set because it's written in set braces, so the first rule is satisfied. The second rule is every element in set A needs to be in set B. There's a 1 in A, there's a 1 in B, there's a 2 in A, there's a 2 in B. Every element in set A is in set B, and that's all I need to be a subset. You need to be a set that's contained, so that is going to be a part of my answer to example 2. Move on to the third symbol. Is B a subset of A? Well, for B to be a subset of A, I need to satisfy two rules. B has to be a set, and every element in B, the second rule, needs to be contained in set A. So B is a set, so that rule is satisfied. Rule 1 is satisfied. But rule 2 isn't satisfied because there's an element in B3 that's not in A. So rule 2 is not satisfied, so this one I'm not going to include in my answer. Because to be a subset, you have to be contained, and 3 is an element of B that's not in A, so it violates rule 2. Go on to the fourth symbol. The fourth symbol says, is A a proper subset of B? Well, to be a proper subset of B, for this symbol to be true, I have to satisfy 3 criteria. The first criteria is A is a set, and it's a set because it's written in set brackets. The second criteria to be a proper subset is every element of A has to be in B. The 2 elements in A are in B, so it meets the second criteria. And to be a proper subset, you're not allowed to be equal, and A doesn't equal to B because the B has an extra element in it. So this is also going to be a true statement. So A is both a subset and a proper subset of B because it meets the 2 rules to be a subset, it meets the 3 rules to be a proper subset. Last object I need to check is B a proper subset of A. I need 3 rules. First rule, B has to be a set, which it is. Second rule, B has to be contained in A, and just had a hiccup on my video. Hopefully that worked out okay. So there's 3 rules that need to be satisfied for B to be a proper subset of A. First, it needs to be a set. Second, B has to be contained in A, and B has the number 3 in it that's not in A. So this violates the second of the 3 rules. So that's not true because it needs to make all 3 rules satisfied to be a proper subset, which it doesn't. So the only choices that were true were the 2 choices that have A a subset of B and A a proper subset of B. So the answer that I wrote for this problem is A is a subset and A is a proper subset of B. So now we get a bunch of homework problems that beat this to death, so you can get good at this, stating the rules, the options that are true. So let me go through my problem 20, and you can do your problem 19. There should probably, that's completely fine. So my 20, I'm going to look one rule at a time. First rule, I'm going to ask myself, is A equal to B? Well, A has the colors red, white, and blue. B has the colors red and blue. This one's going to be a no. They're not equal, because to be equal, they have to have exactly the same elements, so that's not good. Second object I'm going to check, is A a subset of B? there's two things I need. A has to be a set, and A is a set. And the next thing I need is every element of A is also an element of B. And this is where I violate here, because the element white is in A, but it's not in B. So I violate that rule because it doesn't meet the two rules, only meets one of the two rules. I can't put that in my answer. Next, is B a subset of A? To be a subset of A, B needs to be a set, and B's a set because of the set braces. And then rule 2, every element of set B is also an element of set A. The two elements of set B, red and blue, are also elements of set A. That rule is satisfied. That's going to be part of my answer. Let me move on to the next symbol. A is a proper subset of B, and pull out another sheet of paper for that. So to check to see if A is a proper subset of B, I have 3 rules. The first rule is A is a set. That's fine. A is certainly a set. Second rule, every element in set A is also an element in set B. The 3 elements of A are red, white, and blue, and there's one of those elements, white, that's not in set B, so that's violated, and I don't even need to check rule 3 because rule 2 is violated because there's an element in A that's not in B. So I'll move off of that. On to my last choice, is B a proper subset of A? So for 3 rules for proper subset, first, B has to be a set. B is a set because it's written in set braces. Second rule, every element of set B is also an element of set A. We already talked about that. B has red and blue, and those are in set A, so that's okay. And 3, to be a proper subset, the two sets can't be equal, and they're not equal to each other, so that's satisfied. So B is also a proper subset of A. When I go to write my answer for problem 20, I'm going to write the symbols that were true, which is B is a subset and B is a proper subset of A. My answer to number 20 is going to be B is a subset of A, and B is a proper subset of A, and B is a subset of A. Yuck, yuck, yuck. So many of these, and they take so long. So hopefully you can figure out a way to do them quicker than I'm going through these. So let me look at 22. First choice, is A equal to B? The answer is yes, because they have exactly the same 3 elements. So this is going to be part of my answer to problem 22. Now I move on to the next symbol. Is A a subset of B? And there's only 2 criteria. A is a set, and A is a set because of the set braces, and every element of A is also an element of B. And that's true because there's 3 elements in A, every element of A, B, and C are also in B. So this satisfies both criteria. So that's going to be good. Let me right under this, look at this one next, is a proper subset of B, because I have the same first two rules, but the third rule, it says that A can't equal to B, and this rule is going to be violated. So although A is a subset of B, it's not a proper subset of B because proper subsets don't allow the sets to be equal. Let me move on backwards and see if B is a subset of A. For B to be a subset of A, we need two criteria. B has to be a set, and B has a set braces, so that's good. And then the second rule is every element in set B is also an element of set A. And B has a C, a B, and an A that are also in set A. So that rule is satisfied. And for this problem, that's going to be also true. The only one I haven't checked is B a proper subset of A, and the two rules for B being a subset of A need to be satisfied, along with B can't equal to A, and B and A are equal to, so this rule is violated for the proper subset. You need all three rules to be good. The third rule is violated when they're equal, so that symbol's not true. The three symbols are true are going to go in my answer, and the answer to problem 22 is going to be the symbols A equal to B, A is a subset of B, and B is a subset of A. So you might be able to speed through these a lot quicker than I'm doing these. I hope you can. So let me go through 24 real quickly. So for 24, I'm looking at the sets, first trying to figure out if A is equal to B. For A to be equal to B, they have to have exactly the same elements. They don't have the same elements. So I'm going to say no, because 2 and 5 is in A and not in B. Let me move on to both. Is A subset of B? To be a subset of B, A is a set. That's okay, but the second part's not going to be good, because the second part is every element in set A needs to be an element in set B. And that's not good because A has those two elements, 2 and 5, that are not in set B. So this rule 2 is violated, so we can't say that A is a subset of B. Let me move on to the proper subset next, because for A to be a proper subset of B, all the two rules for being a subset need to be satisfied, and it can't be equal. Because the second rule for being a subset is not satisfied, A is not a proper subset of B. Two more symbols to check. So far I have all three false. So next symbol I'm going to check is B a subset of A. And there's just two rules. First rule is the low bar rule, B is a set. Because B is written in set braces, it's considered a set. Second rule, every element in set B is also an element in set A. B has the number 7 and 9. Every element in B, 7 and 9, is also an A, so that's also satisfied. The two rules to be a subset are satisfied, so that's going to be part of my answer. Now let me worry about proper subset, because it's only one more rule. So the two rules to be a subset need to be satisfied to be a proper subset, and then I need that extra rule to be a proper subset is that B can't equal to A, and these sets aren't equal. So B satisfies all three rules to be a proper subset of A. It's a set, it's contained, and it's not equal to A. So that rule is also satisfied. My answer for problem 24 are going to be the two that I haven't crossed out because they were false. So my answer is going to be B is a subset of A, and B is a proper subset of A. Your answer should be similar, except the A is going to be first and the B second. I believe 23, A is going to be a subset of B, and A is going to be a proper subset of B. I can do all of these problems kind of in my head without showing any work. Hopefully you kind of get to that point where you can do it too. Let me do 25 just to knock out one of your homework problems. So let's work through 25 together, or pause the video and do 25 and then check to see what I've come up with. First test, is A equal to B? They have exactly the same elements. No, they don't have exactly the same elements. I'm going to say no, because A has a C in it and B has a D in it. So that's not true, because to be equal, you have to have exactly the same elements. They don't have the same three elements. They have A and B in common, but they don't have D. So that's no good. Move on to A being a subset of B. So A has to be a set. There's two rules to be a subset. First rule satisfied. Second rule, every element in set A is also an element in set B. That's not true, because there's an element C in set A that's not in set B. So this rule is violated, so A is not going to be a subset. It's going to be real easy to jump on and do A as a proper subset, because for A to be a proper subset of B, you have to satisfy the two rules to be a subset, and you can't be equal. Because it violates the second rule of being a subset, it can't be a proper subset. Whoops, this is the one that's going to be violated there. Haven't actually crossed that one out just yet. I said of prematurely doing that. Let me move on to B as a subset of A. For B to be a subset of A, B has to be a set, which it is. It's in the set braces. And then every element of set B needs to also be an element of set A. And this element D is in set B, but it's not in set A. So I violate that rule because there's an element of set B that's not in set A. It makes it not a subset. And if something's not a subset, it can't be a proper subset, because to be a proper subset, you have to satisfy the two rules of being a subset, and you can't be equal. So this is also going to be no, because it violates that same B is not contained in A, or there's an element of B that's not in A. So I've crossed out every single choice other than the none of these. The answer to problem 25 is going to be none of these. Oh, right. Whew. I'm tired of doing these, and we still got a handful more to do. 1, 2, 3, 4 more to do. Let me try to just push through them a little bit. So 28 gives me something in set builder notation. It says set A is a set of X, so the X is a natural number and it's less than 5. So the natural numbers that are less than 5 that don't equal to 5 are 1, 2, 3, and 4. So I had to figure out that A is the set 1, 2, 3, and 4. And now I can go through and figure one at a time. Figure out, is A equal to B? They're not equal because they don't have exactly the same elements. So that one's going to be no. Now, is A subset of B? Well, A is a set. That's satisfied. The second rule is every element of set A is also an element of set B, and that rule is going to be violated because A has a 4 in it that B doesn't. So that's going to be a no. That rule's violated, so A is not a subset of B. And then immediately I can say A is not a proper subset of B, because to be a proper subset you have to be a set. You have to satisfy rule 2 that every element of A is in set B, so that's going to be violated as well. 2 more to check. So is B a subset of A? For B to be a subset of A, B is a set, because it's in set braces. Good. And then every element in set B is also an element in set A. And that's good because the 3 elements in B are also in A, so that's good. So this one's going to be true that B is a subset of A. Last choice is B a proper subset of A. I have to have the 2 rules for being a subset, and the sets can't be equal. And those sets aren't equal to, so it's also a proper subset. It satisfies the 2 rules of being a subset, and then the 3rd extra rule for them not being equal. So that's also going to be true. My answer to 28 is going to be the 2 that I have circled. And so my answer for number 28 is going to be B is a subset of A, and B is a proper subset of A. So you can give 27 a go. Yuck, yuck, yuck. I've got like 5 more minutes before the video hiccups again. I think that's where I'm going to stop. I might not wind up doing every problem. So let me look at my set for number 30. Set A in 30 is a set of natural numbers that are greater than or equal to 5. My set is going to be 5, 6, 7, 8, 9, ... This is my set A. It's the natural numbers that are greater than or equal to 5. It's an infinite set. Now let's look at the choices. Is A equal to B? They're not equal because B has a 4 that A doesn't have, so that's no good. Is A a proper subset of B? I'm trying to do these a little bit faster. To be a proper subset, every element in A has to be in B. If I look at the elements of A, 5 is in A, 5 is in B, 6 is in A, 6 is in B, 7 is in A, 7's in B, and then the ... means yes. So this satisfies the 2 rules. Is A a subset of B? It's a set, and every element in A is also in B. So it satisfies both of those, so that's true. Let me look at A as a proper subset of B, because to be a proper subset, it has to be a subset, but it can't be equal. So it satisfies, it's a set, every element of A is contained in B, and it's not equal to B, so A is also a proper subset of B. To look at the B as a subset of A, this one's not going to be good, because although B's a set, B has a 4 in it that A doesn't have. So this is going to violate rule 2, because B has the number 4, and which A doesn't have. So that's violated, and then immediately B is not going to be a proper subset of A, because the same 2 rules that are necessary for B to be a subset of A are part of B being a proper subset, in addition to the 3rd rule that they can't be equal. So that's also no good. So my answer to problem 30 are the 2 that I have circled. And the 2 that I have circled is A is a subset of B, and A is a proper subset of B. Ooh, I've got 3 minutes before the video hiccups. Let's do 31 and not do 32. So, 31. A is a set of natural numbers in between 2 and 9, not including 2 and 9. A is going to be 3, 4, 5, 6, 7, and 8. So it's natural numbers between 2 and 9, but not including the 2 and 9, and it's 3 through 8. Real easy to do this one. Absolutely, those two sets are equal. They're identical. So part of my answer is going to be A equal to B. Now I'll move on to, is A a subset of B? Well, A is a set. That's true. And every element in set A is also in set B. That's also going to be true because every element, 3, 4, 5, 6, 7, and 8 in set A are also in set B. So this is absolutely a subset. To be a proper subset, for A to be a proper subset of B, A can't be equal to B. And because A is equal to B, it violates the third rule of being a proper subset, so I'm going to cross that out for my answer. Let's see now if B is a subset of A. For B to be a subset of A, B is a set, which it is, and every element of B, 3, 4, 5, 6, 7, and 8, has to be in A, which it is. So it satisfies that, and it doesn't have that third rule about being equal, so this is going to be okay. The last one I'm going to check on to see if B is a proper subset of A, and that rule doesn't allow the sets to be equal. This is violated when the sets are equal, so I'm going to throw that out. For problem 31, the 3 that I have left boxed are going to be part of my answer. Is going to be A is equal to B, A is a subset of B, and B is a subset of A. So just one more to do. We might as well just get it. Oh, there's actually, oh my gosh. Oh, there's even more to do. Sorry about that. I lied. I didn't realize there were more problems. So let me keep going then. Ugh, this is going to be a monster video. So I'm taking a vote. Hopefully you know how to do enough of these. If you want to skip 33, skip 33. I'm going to skip 34. I feel I know I can do it, and hopefully you don't need to see another example. But if you try 33 and can't get it, let's talk about it in class. All right. One last group of problems. I didn't realize there was a last group hanging on there. I didn't get to the end of the section when I was previewing it this morning. So I need to answer true or false, and these are just subset or proper subset statements. 35 says, the letter C is a subset of the set that contains A, B, C, and D. This is either a true or a false statement. This is a false statement, and in order to be false when we have the subset symbol, one of the two reasons needs to be violated. And the reason that's going to be violated is C is not a set. I didn't give a name to these sets. I just give you kind of the right-hand sides, and we have to figure out if it's a true or a false statement using the rules that we know. So let's move on to 37 and 38. So 37 is the set that contains A, B, and C, a subset of the set that contains A, B, E, F, and G. To be a subset, you need to satisfy two rules. The left object needs to be a set, which it is. The second rule is every element in the left set has to be in the right set, which it isn't. The left set has the letter C, which is not in the right set. So I'm going to answer true or false. I'm going to say this is a false statement. And why is it a false statement? The left set has the letter C, their element C, that is not in the right set. The first set, or the left set, has a C, which is not in the right set. So, Rule 2 is violated. Your answer for 37 should be real similar. So let's look at 39 and 40, see if we have subsets here. My 40 has a different answer than your 39. Let's do 39 then. Is the set containing 1, 2 a subset of the set containing 1, 2, 3, 4, and 5? There's only 2 criteria. This has to be a set, which it is, and every element in the left set needs to be contained in the right set, which it is. This is true because it satisfies the 2 rules of being a subset. 41 and 42, let me do 42. It's going to be the same as 41. So, is the set containing the letters A, B, and C a proper subset of the set containing B, C, and A? To be a proper subset, we have 3 rules. It has to be a set. Every element in the left set has to be contained in the right set. And the third rule, the sets can't be equal. I'm going to say this is a false statement. And the reason it's a false statement is the sets are equal, and this symbol doesn't allow the sets to be equal. So I can say the proper subset symbol doesn't allow the sets to be equal, and they are. So the reason it's false is the sets are equal. So somehow in your answer you need to say it's false because the sets are equal. That would be completely fine answer. This would also be fine, saying false. This proper subset symbol doesn't allow the sets to be equal, and they are equal. So your 41 should be real similar. And our 43 and 44 should be similar, and that's going to be the last problem that we'll have to do for this horrendously long section. Is the set containing the letters A, B, C, and D a proper subset of the set containing A, B, C, D, and E? I need 3 criteria. First criteria is the left item is a set. Second criteria, every element in the left set is also an element in the right set, so it fits the second criteria. Third criteria, the sets can't be equal, and they're not equal. I'm going to write true, and I don't need to write a reason down when it's true because it's a true statement. So that's a monstrously long section. Sorry about the length.